already not out in the workforce, you will be out in the workforce. Okay? And hopefully you come across some kind of an employment opportunity that will offer you raises. Okay? Raises are always good. Okay? There are a couple of different kinds of raises out there. There's an annual percentage increase. If you find a job with an annual percentage increase, take it and stay there for the longest that you can. Okay? Because the longer you stay there, the more money you're going to make. Okay? And if the other one is annual, just an annual raise of a certain amount of money. Okay? The reason that I have those compared up there is to show you that if it's a set amount that you are increasing every year, that is an arithmetic sequence or series, depending on the type of problem. Okay? And that was from like what we did last week. Okay? If it's a percentage, it is geometric. Okay? So an annual raise of a set amount of money, $1,200, in this case, $1,200 every year, that is arithmetic because the difference is always the same. If it's a percentage increase, then that is geometric, and therefore you would use the different geometric formulas for it. Okay? So, here we go. Starting salary at the What's It company is $29,000. And the What's It CEO is offering you a 4.5% per year raise. Okay? My question to you is, what is your salary in year 20 of employment? And how much total money has What's It paid you over the first 10 years of you being there? Okay? Go for it. What's my R value? 4.0. Nope. Nope. What's CC? 1.45. It's 1.045 actually. If it's less than 1, it's decreasing. Okay? Now, so if it's going to be increasing, it's got to be bigger than 1. Okay? So we add the percent that it's going up every year to 1. Well, can't add percents unless they're in decimal form. So the decimal form of 4.5% is 0.045. So add that to 1, gets me 1.045. So what then is the formula that we're going to use for this particular scenario? G sub 20 is equal to 29,000 times 1.045. So raised so that really it's 20 minus 1, but we'll call that 19, right? Okay. So 29,000 times 1.045 raised to the 19th gives me $66,927.95. What if I put 66,927.949? That's not a cent value. You've got to use your brain as to what you're going to round to in these word problems. If it's a dollar amount, you're rounding to the nearest cent. If it was a person type problem, you're going to round to the nearest weight type problem. We're going to have grams a little bit later on. Then what can we round to? If it's a weight type problem, if it's grams or pounds or feet, a distance problem, or a time problem, does it matter? No, those don't matter what you round to because you can have part of a second. You can throw your calculator across the room. Exactly. Okay? You can, you know what I mean? You can have part of a gram. You can have part of a pound. Okay? You can have cents here. Okay? At least 3. Yeah. Minimum of 3. Yeah. Okay? If you go up, okay? Alright? What is the total salary for the person's career after 10 years? So now we're talking total salary. What does total salary mean? Mm-hmm. Yes. Up. Enter. Because it's not rounded to the nearest cent. Okay? Alright? Okay? So, total salary means what again, Cece? Sum. So we're talking the sum here of the first 10 years. So that's S sub 10 is going to equal what? What's the formula? 29,000 times 0.45 to the 10th, then minus 1 divided by 0.45 minus 1. Okay? Alright, so let's figure that one out. Raised to the 10th minus minus 1, then 1.045 minus that, and what do we get here? I get $356,358.07. If you don't like to use parentheses on your calculator, then you're going to want to start on the inside with just this. Okay? And you're going to want to say then 1.045 to the 10th equals minus 1 equals times 29,000 equals. And then if you don't want to do this math in your brain, then that would have to be divided by in a set of parentheses for your denominator. Okay? What most 9 times out of 10 you'll be able to do that in your brain. Okay? Questions on that? Okay. A ball is dropped from 6 feet. When the ball bounces, it rebounds to 75% of the previous height. Find the total distance in feet that the ball travels in its first 7 bounces. Okay? So, logically speaking, a ball bounces. Tennis balls don't bounce as good as. Okay? A ball is bouncing, rebounding to 75%. What is going on with the actual ball? It's going both up and down. So it starts by going down how far? 6 feet. Okay? So it first starts by going down 6 feet. Then what happens? So how far does it go up? Back up 4.5 feet. No. It'd be 4.5. Because we're dealing with feet.
Right. So the half of the foot isn't 5 inches.
But we're not dealing with inches. We're dealing with feet. Okay? Then what happens?
Goes back down 4.5.
Then it goes back down 4.5 feet. Then what? Goes up how far?
3.375.
3.375. And so on and so forth, right? So how many bounces is that?
2.
That's 2 bounces, right? Okay. So, looks like 2 sums to me, right? A green sum and a purple sum. So the green sum would have what for its first term? What would be the R value? 0.75. And what would be the N value? 7, right? Because we want 7 bounces. Okay. So that sum is going to be what? What do we get for total distance traveled on the way down? Kelly, I have 2 balls in my hand. Don't make me throw one of them at you. Use one of mine. I know. Don't make me use one of them. What we got? I did everything but calculate it out for you. NQH, what'd you get? Okay. Would you be offended if I rounded that to 20.7964? Okay, good, because that's what my calculator tells me. Okay? Is that my answer?
No.
Why not? You gotta add what?
You gotta add with the next equation.
The purple one?
Yeah.
So, because now with the purples, now that one's starting at 4.5. What's my R value? 0.75. What's my N? Okay. So that would have a sum of 4.5 times 0.75 to the 7th minus 1 all over 0.75 minus 1. Okay. which should be 14.7964, right?
Yeah, 15.5973.
But it's, the only thing that's different is we didn't do the 6, right? Right? Why is it not just 14.74 or 7964? Because the only thing that's different in the green and the purple is we didn't have that first 6-footer, right? So why do I get 15.5973? Why is it not 14.7964?
Because the ball doesn't have the same velocity.
What do you mean you have another bounce?
Because you have 7 bounces, so if you took that one away,
So if you take the 6 away,
you have another one at the end.
you have it going up at the end. Exactly. Thank you. Okay? Because you got the going up at the end that you add in. You can't just take away that 6 and just subtract 6 and not have to recalculate it. Okay? So now if I want to find the total distance that that ball traveled, what do I have to do with them, Michaela? You got to add those two up. Okay? So the total distance here is 36 point, we'll call it 394 feet. Okay. Certain strain of bacteria decays over time. If 87% of bacteria is left every day, how many grams are left after 12 days? If there were 1,456 grams at the start of day number 1. Go for it. First thing you got to ask yourself, is this, am I finding a value or am I finding a sum? Finding a value, right? I'm not asking for the total. Okay? Yep. Not finding a value. We're not finding a sum. We're finding a value. Okay? There's no word of total in there at all. Okay? So, what do we need if we want to make our rule? Our rule, remember, was G sub n equals G sub 1 times R to the n minus 1. What do we need? R is what? It's not 0.13. It's what? 0.87. That's not what this problem says. This problem says that there were 1,456 bacteria on day number 1, right? The next day there was 87% of that left over.
So you couldn't do it the other way.
No. Okay? Alright? So that tells me that, so the first term would be 1456. Then the next term would be 1,266.72. Then the next term would be 1102.05, and so on and so forth. Right? Okay? So R is 0.87. Okay? What else do we need? What's G sub 1? $1,556. What else do we need? What's n? No! No! No!
What's the question?
What's n? Why is n 13? So if we write this out, if I got day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? I had 12, but that's okay, right? So this says the start of day 1, there was 1456, right? Okay? So that means if I go out 12 days, that's the start of day 12, correct? What are we asking for? After 12 days. So that is right there. So n is 13. Because you have to add in that 12th day. Okay? Now we got enough to go. So now G sub 13 is going to be the start of the 13th day, which is the end of the 12th day, is going to equal 1,456 times 0.87 to the 13 minus 1 power, which is 273.774. Okay? Do I need to round to anything? Why not? Because I'm in grams. I'm not in actual bacterias, okay? Or bacteria. I'm in grams, so the only thing that I have to add then is my label. Okay? Logic is going to hurt you. The math isn't going to hurt you. The logic will hurt you in this. Okay? Take your time, read the problem, make sure you understand, comprehend, if you will, what it is that the problem is asking and where it's